Hey there, my name is Chris. I'm the developer behind Blackout. This is a game that was made for the UE4 Summer Jam. It was made in 5 days. And in it, you play the role of Steve, the scuba man, who's trapped in an underwater cave, and you have to make every breath count, navigating various obstacles and finding your way out. So I'm going to go through just kind of a few of the notable items, like not everything obviously, and hopefully if you're a fellow UE4 developer, or perhaps you're just curious, you might find this information quite useful. First thing you'll notice is that the level itself is actually a landscape that's been rotated 90 degrees. At the very beginning, I was toying up whether or not to do a flat landscape and just have the camera look down from above. But then I realized that it would actually be really helpful for effects like gravity to just leave it at like this 90 degrees offset, so that I can still use gravity as and when I need to. The other advantage of using a landscape is that it's very simple to create new sections of the cave just by painting it in using a brush. I guess the other thing you'll notice is that this level is extremely intricate. There's lots of overlapping colliders, there's lots of helpers that I made. This is a really big tip for when you're doing a game jam. Spend the time making little blueprint helpers. So, for example, this one here, which allows me to place groups of stalagmites. And that's important to be able to control the collision box, because this is what actually attaches a rock spike to a player when they pass into it. A lot of the other items that you can see are just, standard foliage brush that was added to the last minute. So one of the cool level blueprints that I made was a water towel placer, and it's currently disabled, but I'll enable it now. If I enable it here, you'll see that it's actually added a whole bunch of planes to the level, starting from the origin point here. And actually what it's doing internally is it's checking for these colliders right here, and if it finds one, this is like essentially what is an air pocket, that's what I've called them. If it finds one of these air pockets, then it doesn't place a water towel there, and that's how you get this sort of impression of there being space there. But then everywhere else we obviously get these tiles placed down, and I mean, I found that this was the best way to get it nice and performant too, because having one massive plane take up the whole level was just not working. Whereas this way, because they're all instance planes, they get cold as needed. You can see some of the code here where it basically just divides it up according to the grid that I set. It's a bit messy, but that's a game jam for you. And then it does this trace to look for these colliders, along with a few other things, because I found there was some edge cases, and adds an instant static mesh, which is the water plane that I was talking about. The water shader is actually quite cool because it's incredibly minimal, really. When I was experimenting, I just wanted something that would just give the illusion, but nothing expensive, because I realized it was going to be a big part of it. So actually what I've got here is essentially 4 parts. There's a color component, an opacity component, which is the depth fade, so that it kind of, as you look further into the back of the thing there, it sort of gets more and more intense with the color, and then clearer around the edges, and it gives it kind of a nice kind of contrast. Distortion, which is basically what gives it these ripples, and the final part is refraction, which gives it the reflection effect that, I don't know, I kept it kind of minimal for this, but it is important. It helps add that realism to it. The other thing as well that, if you are paying attention, you might notice is in the game this is all black. This edge case here. I don't know if this is the best way to do it, but this is how I did it. You'll notice that the whole level is placed very precariously at the 0 mark, the y-axis. So everything that's behind that 0 mark is the level. Everything that is above that is in this post-processed material is black. So if I open that up, obviously right now it's disabled so that you can see, but it makes everything black pretty quick. There's some other stuff going on, which is why it's got this horrible red area, but if I show you, yeah, this is quite, here we go, right here. So if the world position is greater than our clip position, which is 0, I made it a parameter so I could play with it. There's also like a fade threshold as well, so that we don't just cut straight from black to white, we actually fade it a little bit too. And then we lerp that between what the post-process has given us. And also this, it's not true black, it's like a blue, but between the blue and red, that when the player takes damage, I add a little bit of red in there to make it look interesting, but it lerps between that. So another question I had was regarding the currents, the slipstreams that push the player around in certain areas. So these guys right here, both concerning like how to get the effect looking like this, but also how to push the player with it. So this spline mesh, we use a normal spline laid out in the level editor, and you can see we can sort of add new sections like this. And then inside this blueprint, basically work out what the length of the spline is, divided by the size of our mesh, and then at regular intervals along the spline, we work out what the location and the tangent is, and then place a spline mesh component at that location. The material is obviously set as well, and we can adjust the speed of that material. There's another thing in here which makes it fade at the beginning and the end of the spline. The mesh that we're placing is this guy. As you can see, only one side of it is actually UV mapped. The other sides are all blank, and that's because we only need to see it in the y-axis, like this. It's a collider like this so that we can be sure that the character's actually going to cross it. When the character does cross it, we go into this monstrosity. Because it's on tick, it's not ideal, but again, it's about time, and this was the easiest way to do it. But when we enter it, we set a little active variable, on the player. That variable's valid. So we find out which of the actual individual meshes we're colliding with on that spline, and the kind of the direction of that mesh. And every tick we're adding, according to the intensity of the current, a tiny amount of character movement based on that direction that we calculate. And the texture itself for the current, isn't it? Yeah, it is. There is actually a tiny thing in here that basically makes it so that intensity of the current increases and it scales up slightly when the player is in the proximity to it. And the speed of it is obviously just controlled by a panner. So we set the speed and it moves this along faster or slower. Another one that was actually really cool for this project, at least from a experimental point of view, was these, what I've called world hints, and getting this kind of movement effect that makes it look like it's in the water. I was pleasantly surprised about how easy this was to do. Obviously there's a level blueprint essentially, but this plane uses what I've called a texture billboard. Fundamentally it's not that much different from a material billboard, but it gives you a bit more control over what is actually, like I can just basically place the texture in there. I didn't fiddle around making an actual widget and typing it all out. I find that with Affinity Designer and its export tools, it's actually quicker just to do it in there and then export it all as one and re-import it in Unreal than it is to fiddle around in UMG, opening up a UMG widget, typing out text and then saving it again. You can just do so much more with a dedicated graphics editor than you can in UMG. In terms of the game jam, obviously, if you're doing a proper project, you might consider it different priorities for that. But no, inside this material, there's a sprite node which makes sure that it always faces the camera. And then this is essentially what gives it the movement effect. So we're just taking the time, creating a sine wave out of it based on a varying multiplier, and then lerping between two values to either change the rotation or change the X and Z position of it. And you can see it actually works quite well. And I guess one of the last things I'll cover is how I cheated basically with the character animations. So I did want to add proper swim animations. I debated doing it, and you'll see that there is an animation in the background. There's an idle animation running. But one of the things I learned about game jams is that animation takes time, and if you're going to do lots of animations, it will eat up so much of that time. So for anyone who's not familiar with it, there is a physical animation component that you can use. And what this does is it will take a skeletal mesh. With an animation pose, you can apply physics to all of the components inside the mesh. So for this guy. So this physics asset has obviously the different bones. Not very well made, but again, it's a game jam. And I've actually made some adjustments to the constraints as well. So some of them are allowed to move, some of them aren't. The physical animation component, you have to define a few things on begin play. So I think this is the guy here. Yeah. So, you know, set things like orientation, angular velocity, strength. These had to be quite high for some reason on this one. I've not usually had to go so high with it. And this will attempt to try and keep the mesh in that pose position. So in this instance, the animation that I've set here, this idle animation. And you can obviously tweak how much physics plays a role or animation plays a role per bone as well, which is what I've had to do here. For this project in particular, normally you'd want to pull the character. You have a physics constraint that keeps him in one location so that way he doesn't just sink to the floor. Normally you'd want that attached to the hip area on the character because he'd be walking around using his legs. But one of the things that was really curious about this project is that because he's swimming and he's always swimming kind of head first, the constraint, and the fact that there's no gravity for him as well because he's underwater, the constraint is actually added just below the neck height, just here on the torso. I think I can actually show you. If we play the game like this, hopefully it doesn't crash. Yeah, okay, you can just about see it. And obviously there's no water as well, but you'll see that the area that the capsule and the mesh are attached to is just below the head. Again, that works really well when we're underwater because we're pulling from the head, like this, rather than the torso. But also works when we're in the air pockets because it keeps his head and the upper part of his body just above the waterline as though he's kind of floating there. So I thought that was a nice touch. And it's one of those cases where you just have to play around until you discover something like that. It's not something you'd really think would be necessary, but it was, and it worked. Cool, well that's about all I got time for right now. If you got any other questions, feel free to leave them on the video. If you want to try this game, I'll leave some links on there too. And thanks for watching.